Ahora sí, buenos días a todos. Muchas gracias por participar de nuestro ciclo.
Good morning, everyone. Thanks for being here today with us. Today, we are presenting high scalability for Uruguayan COVID schedule applications. And this will be presented by Sabrina Juarez and Gonzalo Galotti, members of our research and development team. At the end of the session, we're going to have some Q&A. So, Sabrina, you have the floor. Hello, everyone. I'm Sabrina Juarez. I'm part of the GeneXus team.
Bueno, buenas tardes a todos.
Gonzalo, okay. Good afternoon. Thanks for being here. I'm Gonzalo Galotti, and I work at the development team for GeneXus. And today, we're going to be talking about two main topics. So these two main topics are, we're going to be talking about a case in which we were involved that basically was the application of the vaccination application for the Uruguayan government, basically an app through which the Uruguayan citizens could schedule to get the vaccine against COVID-19. And then after that, Sabrina Juarez will be showing you how to use GeneXus to develop an app similar to this one using GeneXus. Probably you have no idea what these dates are about, but basically these are the starting dates for some of the countries and the pandemic: Mexico, Uruguay, Argentina, Brazil. In March 13, March 4th, and that obviously that had an impact on the lives of everyone. We had to adapt to this new reality. After that, immediately after the start of the pandemic, and we were all concerned about this, developed countries started this competition to develop a vaccine against COVID-19. So some of the countries got the vaccine, they had it tested, and we moved on to the next stage. That was basically a competition between countries to try to get the vaccine, to try to purchase as many doses as possible. And after that, we moved on to the next stage. Once the vaccines got to the countries, all the countries had to develop a strategy in order to have all the people vaccinated in their countries. Some countries, the countries followed different strategies for that. Some countries decided basically to define some age groups, and then people were supposed to go to health centers to get shots without any kind of schedule. Some of the countries, like Uruguay, for instance, they followed some other strategy. Basically, there was a pre-enrollment on a website, and the citizens were given a date and time and a vaccination center. This strategy, I think it was very, very effective. For instance, I got 3 shots, and it took me no more than 5 minutes in each occasion. So the experience of the users in these vaccination centers was very good. The problem was that on February 26, 2021, we had this app. The issue here was that this schedule, this app that was created by the ministry, was not efficient enough to deal with the scalability for this scenario. What happened is that there were hundreds of thousands of people checking on the app to get their vaccination schedule. And basically, the app was not ready for the high number of people. This was due not because the app was designed correctly, but basically because they adapted an existing system to this one. Basically, the application was not ready for this, and they had to think about something else. This was a lot of pressure for the ministry. There was a lot of criticism by the people and by the media outlets. So several companies in Uruguay, like Consulting, GeneXus, qualified. These companies started working together in order to provide a solution to the issue of users not being able to schedule. Some people just woke up at 4 in the morning so that they can have access to the app. Imagine. So then several Uruguayan companies, and they launched a new version of the app. It had a web interface. The day it was launched, more than 1 million people got their schedule, and it's estimated that more than 2 million people had access to the site. From that moment on, from launch on March 2021 up to June the 30th, 2022, when the app was no longer in use, more than 6,200,000 people got their schedule. So all this platform was always working, no infrastructure problems, no downtime, and in fact, the infrastructure cost was very low. I believe that this application's infrastructure could have been useful not only for Uruguay, but for the whole continent. We thought of a high scalability application from the very beginning. I want to tell you, I want to describe the path that we followed and the decisions we made in each step so that we were able to build this application. And for that, first, I'm going to show you the initial app, the one that was launched on the phase 0 by the Ministry of Health. As I told you, this application, the first one, the first version, basically what they did is to reuse an existing platform that the government was using for some procedures in the country, like taking your ID and those things. They were similar, but not the same. Why? Because if you got a lot of people getting in at the same time, then the app could not support that. It was a monolithic app with a normal database that was deployed in the on-premise data center by the government. So if there was a lot of people requesting the service just couldn't cope with that. The database couldn't cope with that. There was a lot of CPU blocks. Even if you increase the size of the database and the servers, they would reach a limit that could not be enough to answer and to provide a response to the number of people requesting the service. So taking this into account, there were some possible solutions. And these possible solutions had to have some requirements, fulfill some requirements. We knew that this new system, new app that could replace the old one, they should be able to support more than 1 million people, users, at peak times. Another requirement is that performance should be predictable and secure, and the largest limitation was time. We had 10 days to develop, test, and launch. That was the the most difficult barrier, let's say, in the project. And of course, there was a lot of pressure because they really needed to launch the application. They couldn't wait any longer. There was a lot of pressure by the media, by the population. So together with the IT government team, we started thinking about solutions. The first solution that we thought of was, why don't we move all the system to our current premise to the cloud? Basically, we do some vertical scalability. We had a huge database and huge servers, and we include more hardware and more hardware. That is a solution. That could have been a solution, but we were not sure if that was scalable or not. So we didn't choose that option. The second option, maybe we can re-implement the schedule call system. We create a whole new architecture from scratch in the cloud. And that solution was scalable, would require more than 10 days. Why? Because the system I told you about, it was not only the front end for the user, but the vaccination centers were already using that administration side. So changing all the front side clients, as well as the administration in the back end, and the systems used by the government and the ministers to have access to the data would take way longer than 10 days. So we tried to find another solution. So we went back a step and we thought about the problem. The problem here is that we need to avoid that all the people go to the current site at the same time, because the current site could not support the demand of hundreds of thousands of people. So we said, okay, let's focus on this issue then. Okay, let's create a new component that protects the current system. That is the one that deals with all the complex elements about times, vaccination centers, possible vaccines. Let's include a component. You can see there on the left, that would be the new part. And on the right-hand side, you will see the existing part at the time. So on the left-hand side, we thought about having a new component. So the one dealing directly with the clients. And what is the implication of this? So this new component that needed to be scalable was created, was built in the cloud, and it was pretty simple. It had a front end, a web application, a front end in which people would enroll, that triggers a web service to schedule the client or to cancel, and through an API, we had a data store. Also, at the front end, was using an API to get all the data from the schedule, the status, and of course, there was a storage. So this was the new system. Afterwards, I will show you how we made all this scalable. But this was the new system in the cloud. And then something that is missing is how to connect all that information. Basically, all the users that use the new front end, that information for the moment stayed in the cloud. So we need to let the existing system, we need to let it know about the new schedules. So for that, we developed another module that was completely independent, that basically would read from the storage of pending schedules, and then it would insert that in the existing system by the government, and then it would update that information in the database in the cloud. In this specific project, all the components of on the left was not developed by GeneXus, But the part in the middle, it was, and the components on the right-hand side was the existing system at the moment. Why is this system more scalable than the existing one? Well, being in the cloud is not enough. This system was scalable because decisions were made at every stage. What is it that we did? The four components that we identified were the front end. We had to make decisions so that the front end was scalable. Also, we had to basically to make APIs scalable. Also, we had to make decisions so that the storage used to store all the information was scalable. And then all the processing and the sync systems between the cloud and the government app. The main decision that we made was that in all these layers, we had to adopt a serverless architecture. Why? Because we needed that. We wanted the layers to have the very little maintenance. We didn't want to think about hardware, but we want to think about business logic. We didn't want to deal with infrastructure maintenance. We didn't want to have those issues. We wanted to have peace of mind in this aspect. For the front end, in the case of front end, the decision was pretty simple. Basically, what we did is to have the website is a static website, HTML5, JavaScript, sorry. We have a content delivery network, CDN, and that was it. With that, the website that users accessed was 100% scalable because they are static and they're in the cloud. That was the way of solving the first problem. Then that front end was connected to the backend. And in the backend, we had some issues, of course. If we wanted a backend that supported any kind of scalability, 100, 1,000, 1,000,000 people, we could have the same problem that the initial solution presented. We would need to have as many servers, 10, 20, 30 servers to support those demand peaks that take place at specific times in the day. So that was the kind of solution that we didn't want to deal with. We wanted to have something like this, that our system capacity would automatically adapt to demand. So luckily, this model that a system's capacity can be automatically adjusted to demand is a model that already exists in the cloud. We didn't have to invent this. And that model is the model behind function as a service. Basically, all the cloud systems in the market, Amazon, Amazon Lambda, Azure Functions, Google Cloud Functions, basically allowed us to use this model. Basically, a model in which we don't need to worry about servers, and we worry about the business logic and to deploy code. Basically, for you to understand this, this means that instead of deploying code in servers, virtual machines, we simply develop our package in one of these platforms. In this case, we have Amazon Lambda. It can be Azure or it can be Google, as I told you. The good thing about all this is that we have our code in Lambda, and then we have the service definition I told you about in API Gateway. And then when we combine the API with Lambda, is that when we have a lot of people getting into the platform, it automatically gets as many containers or servers as required to deal with the demand. That's why we don't have to worry if we have 1, 2, or 3 servers. Now infrastructure problems are not a concern. Basically, we knew that the application would work whether we have 1, 10, 100, or 1,000,000 people. And that gave us a lot of peace of mind when it came to the development and maintenance of this mass application. We talked about front end. We talked about this stage. So now we need to talk about the database. A database that, of course, should be scalable. If we don't have that, we are not solving the problem. We said, okay, where are we supposed to store data? One option was to use a normal relational database, but that shows the same problem. If we chose this option, we had to plan all this and provide maintenance. So we decided to use a non-relational database. In the case of Amazon, we connected to DynamoDB, and that was our storage solution for the vaccination schedule. Why DynamoDB? Basically because it allows us to trigger requests and it will always answer automatically. There's no limits to that. We don't need to let it know about how many requests are going to have. It automatically deals with that. It can provide a response to any kind of demand. And we paid for requests. We didn't pay for idle capacity. So now that we have these 3 elements, API Gateway, Lambda, and Dynamo, with that, we got a solution in the cloud that was 100% scalable. So it didn't matter if it was 1, 100,000, or 1,000,000 people. We were sure that this solution would work because it was hosted in components that were 100% scalable. Lastly, so when we talked about sync, in this case, since we built 2 systems, one in the cloud, and we were keeping the existing system, we needed some way of providing synchronicity to data. That's why we had an interface between the world of Amazon and the world of the government application. That is to say, when we had a new schedule request from the front end, we could insert that new request in a queue. For that, we used Amazon SQS. Why a schedule queue? Basically because it was scalable 100%, and that would allow us to perform several tasks. Remember that we had some components that would sync the different elements. That would be a solution so that we could, for instance, if in a moment we needed to process a long queue of messages, we could lift 10, 20, 30 instances, and it would let the old system know about these existing requests. If we needed to stop all this, we could turn off all the schedulers, and the application in the cloud would continue working, storing all these messages in the queue. That provided a lot of flexibility to the system. with these decisions that we made, we were able to achieve all this. But all this was in theory. We needed to test it. That's why it was fundamental that in those days, 10 days in which we were developing all this, and I would like to highlight the testing performance, we had a team that was dedicating to the performance testing of the project that could guarantee that the system would perform on high demand. That was very important for the project. There were some articles that were published. Amazon published an article about this, and it congratulated the government on the performance. And I think that even more important was the team. We had more than 14 people working on this, several technology companies. And before we move on to Sabrina, I wanted to tell you that a lot of people worked to make this possible. And what is interesting, the cloud component was not developed with GeneXus. So that's why, as from 2021, the challenge was being able to build these kind of systems with GeneXus. So now Sabrina will tell us about a similar system, but developed by only one person with all these complexities I told you about. Sabrina, you now have the floor. The good news about this is that today, if we had to develop this COVID vaccination app, we would be able to develop that 100% with GeneXus. As he mentioned, as from that moment, the goal was to try to have all the functionalities required, and to do that through and only with GeneXus. The most important thing is that it should be able to escalate without any limitations. So we focused last year and this year on the Amazon cloud and Azure cloud to get started. So in order to provide strong evidence that we could do this with GeneXus, and we created a sample case with all the specificities of the vaccination application. So this example is called Festival Tickets. This was developed by Daniel Bonsa, only one person, with the version 17. Basically, it is an application that allows us to be part of tickets giveaway in concerts that have a lot of people, or a sports events. So it is part of the problem that thousands or million users are trying to have access to the application in a short period of time in order to register and get a free ticket to one of the festivals. So basically, we have the same issue that we had for the vaccination app, and also the same solution. So the users being registered so that they are in a list, and then eventually they would get a free ticket for an event. That request is then that is asynchronic. You may have thousands of millions of users trying to register at the same time. So it would be impossible to do that synchronic. So architecture should focus in asynchronic elements. So there should be a queue for the messages. And by doing that, we solve the issue of the high demand during short period of time. So what are we trying to do here? As it happened with the COVID app, we need to make the front end scalable. That is easy. Then we'll tell you how. We want to scale the compute. So the back end of our Angular application, all the services provided, we want to have them in a serverless architecture. So as Gonzalo was saying, so that we don't have to worry about architecture, so it automatically scales when we have high demand exclusively during user peak. It will automatically scale, and I won't have to concern about structure. And at the same time, to pay only for those peak moments. And then if the platform is not being used, not to pay for that. The same happens with the scaling of the store. For the same reasons I have just told you about, we want our model serverless. And we also need to have an asynchronic process in some specific cases. For instance, during user registry, because they will try to get free tickets all at the same time. So here we can see something like a picture of the different components in this sample case. We have two flows, basically. One would be registry of users. Basically, it's a list in which he or she eventually will get a free ticket, and the other at the top is basically to check the user registry and its status. I'm gonna decompose this into components. So here, what we can see is user registration. It's an Angular app. The client will go there and register in the app. A message will be sent to the queue. That is an AWS SQS. And there will be a function in the cloud that basically will waiting for those messages in the queue so that when every time we have a new message, it will be processed. That will be the Lambda function. So that function will process data of that user and include that in the relational database and in the non-SQL database. That is DynamoDB. Why? As we told you, it is supposed to have 1,000 or million users. So having a relational database could not be the best because they have log consistency checks. So it would be better to use a non-relational database in which all these processes are faster and it's easier to provide response to this kind of demand. That's one thing. Then the other execution flow, let's call it like that, is to check this registration status. There's an Angular application. It has several layers. It has a presentation layer, and then we have a backend that represents the services by that application. And those services can be published in a serverless architecture as Lambda functions. At the same time, these services will have access to DynamoDB, always because of the reasons I told you about. At the same time, we have another Lambda function, but this one is not triggered. It's not triggered by an event, but it's automatically triggered by a specific time. So every 24 hours, for instance, this Lambda function will carry out a ticket giveaway with those users that registered, and that will be stored in the database. That would be the example. That is pretty easy, but at the same time, I think that it clearly shows what to do, and it's very similar to the case of the vaccines. And now I'll show you. I'm going to share screen. And I will show you how to do this in GeneXus. You can see my screen, right? Okay, so basically what I have here, I have a model in which the backend generator is Java and the front end is generated by Angular. Here, generator Angular says here true. And then I have a relational database that is Dynamo and a dynamic data store. So that Angular application, what you're saying, that connects to Dynamo. And how do I work? How do I use Dynamo in GeneXus? The first thing that you need to do, we have an inspector that basically checks all the Dynamo tables, and you can manage those that you're interested in to include in the knowledge database, and that automatically generates transactions for those tables and data views associated to that. For instance, here you have tickets transaction and the ticket data view, and that is associated to the ticket transaction and the data store that is Dynamo. As from that moment, I can have access to the data of this ticket table in Dynamo using Page, New, BC, the same way as I do with a relational database. I can use, in fact, of course, with the specific cases of this not being a relational database, with the limitations that it has, because it's not an SQL database. For the GeneXus user, it's the same. We have the same kind of access. So you said that the Angular application, apart from connecting to Dynamo, also connected to a message queue, right? Exactly, yeah. Remember when during the registration, a message was sent to the message queue. Now it's in beta, but it's going to be in the EU11, a new API that allows us to work with message queues. This is an external object that is part of that API that has all the necessary method. For instance, to see the size of the queue, to send messages, to clear the queue, delete messages, to read messages. So all this can be used in the API. We can use proc, process ticket queue. No, sorry, it's not this one. Let me check on the proc. Yeah, here, queue ticket push. The first thing that it does is to connect, and it connects to Amazon Queue, but also for Azure. Here we get a message with the body and everything, and the message is sent. And with that, you're interacting with the message queue. So the Angular app, what it does basically is every time it gets a new request, includes that in the message queue. But how do I do so that that message is processed by someone automatically, right? So that someone is a Lambda function. So basically the Lambda function in GeneXus is a proc. As a GeneXus user, what I can do is to program a proc, and in the case of Lambda functions that are activated every time a message gets to the message queue, in that specific case, the proc has a signature that is predetermined so that I can get that message and process it. So if I want to have a Lambda function that can be triggered by the fact that there's a new message in the message queue, I have to do a GeneXus proc with this signature with SDTs that are part of a module that I can import in GeneXus. And in this SDT, that is event messages, I'm going to go through these event messages and process each of the messages that are the messages that got to the message queue. So this is something similar to, for instance, having a server, a daemon command line that was constantly checking the message queue. But in this case, it's just one step further. So every time I have a message in the queue, this is automatically triggered. Exactly. I don't have to create a virtual machine, as you said. This is automatically triggered every time we have a new message in the message queue. But something that is important, that this is agnostic when it comes to the cloud. I had a GeneXus proc. I never said that this could be sent to Amazon or Azure. I would be saying that during deployments. During deployments, I would say, okay, this proc, I want this proc to be deployed as a Lambda function or as an Azure function. If you want, I can show you a little bit more about this. Here, for instance, this screen grab of the tool that we have for the deployment tools. In this case, I'm deploying the proc I told you about. And the way of deploying this is to set the trigger. For instance, there are going to be Lambda functions, and the trigger type here is going to be a queue. On the contrary, if what I want to do is to do the Lambda, remember there was another Lambda for the tickets giveaway, and that Lambda is not triggered by a queue, but by a timer that is already scheduled. Okay, let me see if I can show you. In that case, it's the same thing. I will deploy a Lambda function, but the trigger type is going to be timer. We have different types of trigger types for this Lambda function. We have HTTP, but this is defined during deployment. And if we continue talking about deploy, then how would we, what deploy would be like for Angular function? As you were saying, Gonzalo, it would be great to have a CDN to make the most of the scalability to be used in an application that is static. So how do I do that? The deploy, well, basically I choose a front-end deploy target, and I'm going to deploy that in a storage provider of a cloud, for instance, S3, or I could choose Azure cloud storage, or today it can be a Docker image. And to continue with this, how would this backend deploy? Because we have services, remember? The service component, remember that we had decided to deploy that in serverless. These are Lambda function HTTP type. I would like to show you a little bit of the execution of all this. I know we're running out of time, but I think this is the app. So what we do here, first of all, is to subscribe. I will write test so I have a user. Basically, what this does is to send a message to the message queue. And there's a Lambda behind that basically processes that message
ingresarlo a la base de datos del DynamoDB.
and enter that in the DynamoDB database. And what I have here is to work with the DynamoDB table of tickets that I showed you in GeneXus. And as you can see, the user is already entered. So just for you to check that this goes against Dynamo, this is Amazon console that is now checking. It's a select on Dynamo's table. If I click on execute, I could see the user that has just entered, this one here. So I invite you to give it a try. Now in the PPT, I included a link so that you can download the KB. That is a sample that's available. And you can give it a try because the application is online. Now I want you to show some other slides so I can wrap it up.
A ver si puedo. Bien. Bueno, entonces. Opa. Bien, entonces para cerrar, ¿qué estuvimos
So
trabajando?
basically, to wrap it up, this year and last year, we were working in trying to provide cloud functions. Also, we worked very hard with Lambda functions in Amazon and Azure functions. Also, we supported API gateways for both clouds. API gateways are very important components. Also, we provided support for deploy of backend to serverless, iOS, Android, Angular applications. All this, they have a backend, and that backend could be deployed in serverless architecture as options like HTTP. And we also worked in the deploy of static front end, especially Angular application in the storage providers of Amazon, Azure, and clouds, and also as image dockers. When it comes to storage, we provided support in the beta version in DynamoDB. We're also working on Cosmos DB. And also, as I told you before, we have a new API to deal with message queues, that is Amazon SQS and Azure Storage Queue. So I invite you to download this KB so that you can see the code, and also you can have direct access to the front end and try this in execution. Thank you very much.
Y Aníbal, no sé si querés,
Bueno, sí.
te paso la
Okay, Aníbal.
Algunas preguntas.
Yeah, we do have some questions. Some questions were already answered. We have now started the Q&A session. Let me share some of them. Rodrigo Cáceres was asking, when you're using Lambda with GeneXus, can you use any generator? It's only Java. What we did is we focused on Amazon Lambda with Java and Azure with .NET Core. Those were the two on which we focused. So far is those that are mentioned. Sabrina, can you just go one slide back so that people want to copy the URL? Yeah, perfect. I have one more question by Gustavo Ramadan, and he was asking about the containers. Which is the approximate cost of the containers monthly? Lambda charges for execution. Amazon has a calculator that allows you to estimate costs. It is very hard to be charged. You need a lot of demand to be charged. Pricing is in the Lambda website. They charge you by execution, not by the time that you're active. So if it is an application that is not frequently used during specific times of the day, cost is almost zero. That is the difference with a traditional deploy scheme in which you have one specific computer 24/7 for that. We have one question by Michael Cardoso, and I think we have already answered that, but just in case, using Lambda, is it possible that the methods are API and asynchronous? I don't know if I got that question, but I think that by definition, the methods are asynchronic in Lambda because you deploy a GeneXus proc, you tie that to an infrastructure event, for instance, a new message in the message queue, and that proc will be synchronically. For instance, tomorrow I would think of a system in which through which I want to send email message. I would think a message queue that will be mails. All the app's clients will insert the JSON I want to send, and then I will have a Lambda that will be monitoring that queue, and every time they get there asynchronically, mails are sent. I think that by definition, Lambda is asynchronic. Maybe I didn't get the question right. Another one by Gustavo Ramadan that is asking about is Lambda only JavaScript? No, Lambda is Java application. Backend is Java. Java technology. For Azure is .NET. Here we have one that was already answered. How do you do so DynamoDB is compatible with GeneXus? As Sabrina was showing, work with DynamoDB from the programming standpoint, it's the same as a relational database. We have transaction attributes, data providers, business components, which we can work. What we need to take into account is that we won't be able to do the same things as we do with a relational database. For instance, very complex joins that is not supported. It's not connected to GeneXus. Basically, relational databases do not support those things. Database of this type, what they try to do is to try to solve some scenarios. The idea is not to replace all our databases for this new thing. Basically, it's to get to know when to use it. And that would allow us to solve some scenarios. From GeneXus standpoint, we work the same way as in a traditional database. One more question about databases. DynamoDB database, do I have to create that manually? Yeah. What happens is that you can create that in Amazon or Azure, and you can create the table. A non-relational database has no schemes. I can create the table, and then at GeneXus, I can define the attributes, and it's going to work. But the first time you do it, you have to create that on the platforms in the cloud, and then the scheme, you don't need that because there's no one. You just define attributes, and you can start working with the table. Or you can also import it, as Sabina showed.
Ya tenés una tabla andando, puedes importarla.
If you already have a table that is working, you can import that to the GeneXus ID. Jaciel is asking, can we use Netcore for this? Yep, yeah. Netcore is available for Azure. For the time being, it's not available in Lambda. Any kind of mistakes that we need to know, any kind of error that we need to know so that we can avoid and use some other alternatives? We have several examples that are currently working. I think that the errors that can take place can be related to understanding these restrictions that we have. We cannot do the same things that we do with traditional databases. There are more limitations, and maybe those limitations may take us to take more things into account.
Nosotros trabajamos siempre para que, digamos, salga de la mejor manera.
We are constantly working to have the best product possible. We have several examples that are working. It's a technology that can be tested without any kind of problem. Okay, two last questions. Once I have the information in DynamoDB, when is that information sent to the database? Is that done manually? in Sabrina's example, the one that the Lambda that is automatically executed saves in Dynamo and also in SQL. It's the proc Lambda that automatically, when it is called by a message queue, stores both in Dynamo so that the cloud front-end can consult and in SQL in order to do more complex operations. Last question then. The new external object, can it also support RabbitMQ for message queue? That's a good question. No, it doesn't. It supports Azure, Sabrina, correct me if I'm wrong, it's Azure, GeoStorage, and SQS Amazon. Perfect. They were asking if the recording was available. Yes, of course it is in our GeneXus website. These recordings will be available in the 3 languages, Spanish, English, and Portuguese. It's been a pleasure. Thank you all, and thank you to the audience for being here. See you in our next webinar. Bye-bye. Thank you.